Water. It is an essential building block of life, constantly moving in a hydrologic cycle that flows in a continuous loop above, across, and even below the Earth's surface. But water is also constantly moving through another cycle, the human water cycle, which powers our homes, hydrates our bodies, irrigates our crops, and processes our waste. The tight connection between water, food, and energy also makes them dependent on one another. Our increasing need for these three vital resources is forcing us to rethink how we manage and use our water supply.
Water is a challenge because there's so much uncertainty. The hydrologic cycle is highly variable. Societies come to depend on a reliable supply of water in almost everything that we do. So if that's disrupted in any way, there are big social and economic consequences.
With funding from the National Science Foundation, scientists and engineers such as Greg Chiraklis at the University of North Carolina at Chapel Hill are researching new sustainable ways to meet our water needs, studying each connection in the human water cycle to gain more knowledge about the interconnections among water, food, and energy.
If we have an understanding of all of those factors, we can put together the types of rules and the types of what we would call management systems that will allow people to make better decisions.
The water needed to produce our food and energy typically comes from freshwater sources such as rivers, lakes, and underground aquifers. In order to make it safe for drinking, most water must be transported through a water treatment plant to remove contaminants, or in the case of salty water, through a desalination process. Orlando Coronel at the University of North Carolina at Chapel Hill is improving water purification technology called high-pressure membranes, which are able to remove contaminants as small as 1,000th the diameter of a single strand of human hair.
We as humans need water for our daily survival. Most of our body is made up of water, and as a result we need to consume it every day. High-pressure membranes are a great technology, right? We use it to remove these very small contaminants and all sorts of contaminants from the water.
Contaminants such as bacteria, parasites, and viruses that could affect public health. What happens to the water we flush down the toilet or rinse down the sink? It is transported to a wastewater treatment plant to remove organic carbon and nutrients such as nitrogen and phosphorus before it can be safely released back into the environment. Kartik Chandran at Columbia University in New York City is researching new ways of recovering those nutrients from wastewater to produce energy.
Instead of calling this wastewater, to me this is enriched water. We have been able to convert the organic carbon in food waste, in sewage sludge, in fecal sludge to biodiesel, which is a liquid fuel easily transported and easily used, directly used in diesel engines.
Water can be diverted to produce hydropower, the largest source of clean electric energy in the United States. Yet water is essential in other forms of energy production too, such as coal, gas, and nuclear power.
It's brought into the plant, it's used to cool, and then the warmer water then is delivered back into the stream.
Our food supply is reliant on water. In dry regions such as the California Central Valley, the Texas Panhandle, or the high plains of Kansas, irrigation or the delivery of water to crops artificially is vital to the success of a farmer's crop yields. Without the additional water to supplement natural rainfall, fields would go dry and food production would plummet. Irrigation often leads to something called soil salinization, an excess of salt left over after water evaporates or transpires, preventing plants from taking in water and nutrients. Megan Mauder at Carnegie Mellon University is working to improve desalination methods and soil salinity data collection to help farmers make better water management decisions for the future.
In the past, we've been entirely dependent on manual sampling of soils around the country. And while that's effective, it's both cost intensive and labor intensive. If we can predict the soil salinity using satellite data, we could both get higher resolution measurements of soil salinity throughout the United States, but we could also scale this up to global areas where we believe that soil salinization is a concern.
While there are many challenges placed on our water, food, and energy security, scientists and engineers are asking questions and working towards solutions that will benefit us all.
How do we manage the water that we've got? Do we build more reservoirs? Do we develop more efficient technologies? These are all questions that come into play when we try to think about how are we going to ensure a reliable water supply well into the future.
2 water cycles, one natural, one human-made. Yet both are fundamental to meet our growing needs for water, food, and energy.